So the force between 2 point charges takes the form K charged 1 times charge 2 over r squared, which is the distance between them. Then you have the potential U of the two charges. So the potential is basically the same equation, just times R.
Times R.
Yeah, the potential is the energy, the potential energy between the two charges. So when they finish like repelling or
so
attracting,
multiplied by the radius, then one of those cancels out.
yeah. Because if you go back to, if you recall, ordinary kind of mechanical physics,
Yeah.
the force times the distance moved is the work done.
Yeah.
So F times R, work done. That's potential.
Now moving on to single point.
A single point, yeah, the potential for a single point,
The U.
well, it's V. It's V now.
Oh yeah. V.
Yeah, V.
P.
No, it's not. It's in Italy.
Okay. So
V.
V
V.
equals K Q
Over R.
R.
And
Which
that's
is single point.
that's when you have a charge, and you have a test positive charge from, and the potential is the work done per unit charge in bringing that small positive test charge from infinity to that point.
Or if they're the same, then from that point to infinity.
Well, no, you just change the sign.
But the test charge is always positive.
It's always positive,
So
and it always comes from infinity to the point.
okay.
So if it was if it was
You
a
have to
positive
say
charge,
if it's negative. If it's positive Q, you have to say that it's negative Q.
yeah. So if
So
it's
that it's
if it's like a negative
no.
charge, if it's a negative charge, then you'll have a negative actual potential because you won't actually have to put work
Yeah.
in to get it to go towards the charge.
Okay. So it is. What's R?
R is the distance between. Well, it's the distance between the test charge and.
So from where it starts, the starting point.
Yeah, so basically any distance from the
Yeah.
point.
So P test charge.
So if you were to put R into that equation, you'd get the potential energy. Well, the energy it took to take that test charge from infinity to that point close to the charge.
To infinity.
Yeah.
And then K Q over R squared is the field strength of the one.
Yes.
So F
Well, E.
E field strength of
Of the charge. Because if you wanted to find the force between two charges, you just times the field strength by the other charge and you would get the force between the two charges.
yeah. We're not really teaching anyone anything here. We're sort of just talking.
I'm
That's
learning.
okay.
Okay.
Me too.
So that's all you really need to know.
Yeah, you don't really need to define what epsilon naught is.
No, epsilon naught is the
8.854 times 10 to the
permeability
minus 12.
of free space.
Yeah,
Yeah.
it's permeativity or
But-
permeability. One of the two.
Permeability.
So
You could do that.
the force between 2 point masses
Yeah.
is equal to. Oh, nice. Is equal to big G of mass 1 times mass 2 over r squared, following the inverse square law.
Yeah.
So to find the field strength,
Which is E. Is this still 2 points?
yeah, this is 2 points. Well, yeah. Well, actually, let's do the potential.
Yeah.
shall we? So to
U-
find the
U-
potential. Of,
G, little g.
No,
U.
UP
UP.
is negative g mass 1 times mass 2 divided by r, which gives you the energy it would take to bring a small test mass from infinity to that point. Well, infinitely far away to that point.
At what point?
To that distance away from the mass.
What mass? We've got 2 masses here.
Yeah, I know. So,
The centre of mass.
yeah, so that gives you... That equation gives you the energy...
You got another long piece of chalk?
Just use a small bit. That equation gives you the energy it would take for you to bring... So say from mass 1, say that's still, that equation gives you the energy it would take to bring mass 2 from infinity to that distance away from mass 1.
Yeah.
And that's why it's negative, because it wouldn't actually take energy, it would take negative energy, because
Yeah.
the gravity obviously pulls it in.
Okay, so now, ready there?
Mm-hmm.
Okay. Then, we've got single point. Gravity.
So the field strength, G, little g, and that on the Earth's surface is about 9.81 for just if you want to know. But for any mass really,
Yeah.
it is equal to
Any mass.
yeah, it's equal to big G, well big G times m over r squared.
Yeah.
So it's not negative, by the way.
Yeah, it is.
No, it's not.
Yeah, it is.
No, it's not.
Well, if you've got a flat ground and you throw something up, that's positive. So gravity is
We're not talking about potential. We're talking about Earth.
Okay, so it's not negative.
Learning. We're learning.
Okay.
And then
Now, for potential, a point per mass
Which is V.
is v. Yeah. It is negative g m over r, not r squared.
Which is
The energy it takes for a unit mass
yeah.
to be brought from infinity to that distance away from the mass. Nice infinity sign. Excellent.
Infinity to the surface.
Yeah. Well,
The
any
centre.
any point, any distance away, really. That's what r is. The distance from the mass.
Okay. I can represent that with a little arrow.
Represent it.
And then, so the distance from there to there is up.
Yep.
G is 6.67 times
Yeah.
centimeters.
Big G is the
Just-
gravity.
What is this, R?
That r. It's the same distance. So say you wanted to find the strength of gravity in low orbit,
Yeah.
you take however that altitude from the
Okay.
centre of
So
the Earth.
you would be given the actual radius of the planet, for example,
yeah.
to
Or you,
find gravity on the surface.
or you could figure out the radius of the planet if you knew the mass.
Yeah.
Or roughly anyway.
So,
You mean you can't really see that?
Yeah, you can.
Only just.
Excellent.
Nice. Looks like G equals G7.